Here we have a 2 and a 3 input AND gate. This is a truth table. This shows all possible combinations of this. So we have 2 to the second power, which is 4. So that means that we have 4 possible conditions that this could be. So we're going to start counting in binary. 0, 1, 2, 3. So we have a total of 4 possible. Here we have a 3 input AND gate. 2 to the third power is 8. So we're going to have 8 possible combinations from 0 to 7. They work the same way. That this will be the unique condition. The AND gate is going to be high, high, high equals high. So we're going to look for all 3 of these inputs to be high in order to get a high out. Everything else will be a 0. Here we have our 3 input AND gate where we're going to need 3 highs in order to get a high out. So let's highlight all of the highs. Oops. All right, let's convert to the pin and see where we have highs together. So we're going to start off low, and it looks like we got 3 highs there. And we have 3 highs here. And we have 3 highs here. And looks like we got 3 highs here. And that's all. Here's our answer in CAD. So let's take a look. We got 1, 1, 1. Yes. 1, 1, 1. 1, 1, 1. And 1, 1, 1. And 0 all the way out. Yes, we got it. We did good. Here's our 3 input OR gate. So we're looking for all zeros. So let's highlight where all the zeros are at. Okay, that looks right. So let's go ahead and convert to our pin, and let's see where they're all low. So if they're low, that means everything else needs to start off high. So we have a low there. Looks like we have 3 lows there. Three lows there. And since that guy is high, it's all there is to it right there. So it's ugly, but I think we did good. Okay, here's our answer for the 3 lows on our OR gate, and it appears to be identical to the one we have. Much better looking, but the same. Here we have our exclusive OR and exclusive NOR. So these are a little more difficult, or at least you have to pay attention. You could do it 2 ways. You could look for where they're both zeros and both ones, or you could look at it where they're opposite. I think I'm going to try where they're both lows and both highs. And with this one, it would be a low, and with this one, it'll be a high. So let's try that. Here's our exclusive OR. So what I'm going to do is I'm going to eyeball it and use the highlighter yellow to say where they're both high. So let's try this. Looks like both high there, both high there. Okay, let's see if we can change the color of the highlighter here to blue or some other color. There's a pretty blue. Okay, so let's look for low lows. Oops. Yeah, that's no good there, and there. Good, so let's convert to a pen. Other than this little extended, I think we're pretty good. Alright, so when they're both high or both low, that is bad. So what we want to do is, that's going to be a low. So everywhere else that we don't have a opposite, so I think that looks the easiest way to do it. Okay, here's a solution to our XOR problem, and let's check it by going the opposite direction. Look if every one of my lows is opposite. And so far, good. Here's a helper for our lab setup for gates. Okay, so I would use one of our buses there, preferably the blue. I like the blue for ground, and 5 volts red. Okay, and what we're going to do is test these. First thing we need to do is hook up VCC pin 14, and we need to hook up ground to pin 7. And here's an oscilloscope, and we're not going to use this early. But anyway, what we need to do to test these gates is we're going to take a 5 volt in the input. That is a 1. And the ground is 0. So this is a 1, 0. And then we're going to check the output with some kind of a device. Soon you'll get a 5 volt power supply that has a built-in logic probe. Logic probes, you just probe the output and it'll tell you if it's a high or low by the color of the LED. In the meantime, we'll go ahead and we'll do it a little differently. In the future though, it's going to get much more complicated. So my suggestion is use the red ones as positive, use a jumper across, use the blue for ground, jumper across, so you can make shorter connections to the other side. Keep in mind this center trough, there is no connection between the two sides, so the only connections are these 5. Okay, and this is a continuous bus. Not all of these are continuous bus. We got caught with a couple of these that had breaker in the middle. So if you see the red broken in the middle of the board or the blue, that means that it's not continuous and you'll need to put some kind of a jumper across there.